Yep. But I think...
Where are the robots?
Kind of sticking with a little bit of the similar theme today, going to talk some more autonomy. So, a couple of conferences we're at in Germany, it was really apparent. I mean, people's heads are definitely, not just their heads are getting there on autonomy, like people are really experimenting with autonomous vehicles in ag and construction and mining. Nvidia, that I've been looking into specifically around what they call their Isaac SDK, which is a software development kit for autonomous platforms, vehicles, robots. It works on a lot of the Nvidia hardware that we're working with. We'll talk a little bit about that. Really, the pieces. So, like one of the platforms that it runs on, and what's nice is it's actually pretty scalable. So this is the Jetson Nano. This is mine, so I won't hand it around to get touched by everybody. This is the lowest end of the platform. And you can go up to TX2, Xavier, which is like a larger sort of self-driving. We'll talk through kind of some of the hardware differences in a minute. But yeah, that SDK allows you to put together code that's going to run on these modules. And the libraries essentially that are within that Isaac SDK are things like, get data from a LiDAR sensor and turn that into a point cloud and put that into like an obstacle recognition and avoidance algorithm. Like they have that chain of things. They have taking stereo camera input and using image-based feature tracking to do indoor mapping and obstacle avoidance.
Similarly, do they have things for image recognition, speech recognition? I know
Yes.
when we did speech to text, Apple's whatever SDK they had didn't serve our needs, so we had to scratch build that. They've got, what do they call them, gems? They got all these.
They have gems coming for a speech input. It'll be more like command-based versus like a continuous speech recognition like we're doing at Knox, which could have a lot of different paths through the grammar, a lot of complex speech. Typically a command sort of language system is very structured. Now,
so for Knox moving to, that'd still be a full custom.
It would be a plug. So to plug that, so the way you would do that is you would have Knox running on the system, taking audio input in, parsing that out to understand speech happened, turning that speech into text, taking that text, turning that into understanding.
In theory, you could probably even frame it as a gem, like they were talking about potentially. Right?
Yeah, you could make that as a gem, as your own library that you could pull into other solutions. So then you could give it speech input and have it perform a task.
Is there an opportunity to build gems? Was there a marketplace for that? Could we build?
There doesn't appear to be a marketplace yet, but
an AI IP core.
Right. There could be, and similarly for object recognition. So we saw that so the big robot they call Carter, or you can also build the little guy called Kaya, K-A-Y. I assume that's how you say that. That one runs on a Nano fully for the Kaya. Carter runs on a Xavier, which is a bigger processor. The task that thing was doing was trying to, I don't know if everybody caught that, but it was doing image recognition of these objects, and based on how it recognized and classified those objects, it would then sort that. It sees something, it classifies it, it saw, a pear or whatever that was, and it says, okay, I recognize this object as a pear. So now if you wanted something that's not a fruit detector, because that's likely. So these are the things that we've talked about before, right? So a lot of these like AI bits that may come with these platforms aren't right for our problems, and that's where we can come in and plug in with our specialized technology. That's where we can add value. Where we want to make something that recognizes a plant or a other situation or some object of some other type. We would design and train neural network that we could then plug in to that object recognition piece just as a plug-in. So now this robot's capable of recognizing new types of objects.
So if we're not making a robot,
Right.
if we're just making a thing detector, does the SDK do much for us, or is it just the Jetson just gives us a powerful platform?
The Jetson itself is a hardware platform. Like I said, on the low end, there's the Nano. The Nano is capable. We're looking at using that in a number of projects in the future. But it's a tremendously powerful processor. We're going to be able to take in camera input, do full 4K video encoding on it. We'll also do real-time video analytics. Stepping up from there, you have a TX2. That gives you additional processing power, additional memory, but it is very similar in sort of the card module form factor until you step up to the Xavier, which is their newest entrant. That would be a component where that could be the brain of a fully autonomous tractor, planter, whatever. That's got enough power to take, say, multiple LiDAR, 8 cameras, IMUs, time of flight, ultrasonics, radars. You can pull all that sensor data into one platform and process with it, run that Isaac SDK on there to build your application around. Again, if you're doing robotics. If you're not doing robotics, these can just be thought of as amazing edge compute platforms for AI, building cameras around, speech recognition at the edge, any other kind of heavy duty tasks like that.
And what could someone do? Is it just to have fun with the robot? I guess I don't really understand how you incorporate.
So is your question what makes us special as technologists that we can use this tool, and how do we sell that? Is that where you're coming from?
Yeah, I guess in a way that's where I'm going.
So there's kind of two things. This Jetson and Nvidia hardware platforms are very interesting for lots of sensor applications and just heavy processing power applications. Say if we wanted to make a fully autonomous sprayer or fertilizer spreader, we wouldn't rebuild that machine. Maybe we would probably put some additional sensors on it. We would add a processing module that has one of these computers in it. We would use something like the Isaac SDK as like the base to pull in logic, and then we would do the specific job, specific task.
So the stuff they demoed, I mean, they were just using pathfinding and obstacle detection, and whoever wrote that just took the Isaac SDK, wrote a little bit of software,
Right.
and it worked.
Right.
But for our stuff, we might need optical detect of weeds, which might require another bit of AI, which would then change the way we run our sprayers or whatever.
Yeah, sensing a rock or a post or
But going
ditch.
from point A to point B with standard typical stuff that Nvidia talked about
Right.
would just be a little bit of glue code.
So much like we're not going to develop a LiDAR or radar outside of certain cases, like we need to look at some of these tools we can take advantage of and like build on these hardware platforms, these software stacks, and then put our time where it's really valuable and where somebody else isn't going to duplicate it.
Right.
Yeah, so that's a great example that Matt brought up, where it's taking AI tech that we have in the form of the speech recognition, currently runs on the iPad, and putting it in a standalone device.
Doesn't sound like we've got anything that we're thinking about that would use the Newton SDK for let's make a robot kind of a thing. All of our thoughts these days are let's make a sensor.
Yep. But I think
Where are the robots?
that's where I think we should be thinking.
Yeah. So on that video and here it's all, well, here's this, we have this Newton SDK, so you don't have to build your software from scratch, but then you look at the examples of the hardware. People are building hardware from scratch.
Yes.
What, is there a hardware platform that's analogous to this that could get its way through a pig barn, for example?
The one great thing about robotics is it's a highly componentized industry. So the frames, the drivetrains, the wheels, the sensors, highly componentized.
And the reason we're not seeing just a couple of platforms everybody's using is each of these robot use cases needs some kind of cut. Like a pig barn robot's going to be different than a Lowe's wandering a big box store.
Yeah.
So that's why you just have base components, and then somebody like us or somebody else needs to actually build it.
Yep.
I think the big thing is, let's say we started with this Carter Segway based thing, right? We get in there and we find out that the big crap is too deep in some places, and we got to improve the drivetrain. Now, to your point, we drop that part out. Well, even though there's work to be done to like reintegrate that new drivetrain, get that in there, maybe do some little special sauce around like obstacle avoidance, your path planning hasn't probably changed. Your goal level stuff probably hasn't changed. Platform is probably going to move us into places we haven't ever really been before.